How y'all doing? Tom back here again, and guess what? Now it's time to actually finally build something and go. Yay! Up to this point, I've only been showing you like how to utilize certain language features and things like that. But now we're actually gonna build a thing. So what is that thing we're gonna build? We're gonna build a REST API. Um, this is not going to be a tutorial about what a REST API is. I'm going to assume you already know more or less what a REST API is and how it works. But I'm just going to show you an example of how to build one in Go. And not only am I going to build one, I'm going to show you how to build one without using any third-party dependencies. Uh, there are really good third-party dependencies to use to do this that makes this some parts of this much easier. But I'm just going to demonstrate to you that you can actually build essentially a fully fledged REST API just using a standard library. This is not going to have like a database or anything connected to it. It's just going to be using a simple in-memory storage and a slice and stuff like that. So first thing we need to do is we, of course, need to actually get a server up and running. So how do we do that? Well, there is a package, net/http, that you can use to start a simple server. And the easiest way to utilize that is first you need to tell it what port you want to run it on. You can either just pass it straight into the function we're going to call, but I like to define it in a variable here. So I'm going to say it's going to be on port 8080 like this, and then we're going to from the HTTP package we're going to call this function called listen and serve. And the first argument is the the port you want to listen on. So we're gonna pass in the port, and then the second argument generally is just going to be nil. What this actually is you can pass in something to have it handle like the routing on the actual server, but we're going to be doing that later. And I'm just going to wrap this in a log.fatal in case something goes wrong for whatever reason. So you'll see I have a window down here in the bottom left. This is what I'm going to use to be testing the REST API by just using curl to send requests to it. You, of course, can use anything that you would normally use to test REST APIs like Postman or Insomnia or whatever. In this bottom window, all it's going to be doing is I'm just going to be using this to actually run the server, so it's not really going to have any like important information. So I'm going to run the server, and you see we don't get any errors yet or anything. Now we haven't defined any routes here yet. So you'll see if I curl localhost 8080, I'm just going to get a 404 because we have no routes defined at this point. So I'm going to kill my server, and let's add a route for the root path. You have two options for this, like determining how the routing is handled with the HTTP server. If we go over to the documentation, the two things that we're looking for here is handle and handle func. Handle takes in the pattern, which will usually be like, slash, it'll just slash root or slash whatever your resource is, whatever your path is to the endpoint you want to set up. And then it takes in an option of type handler. This is an interface that's defined in the HTTP package. If we look at handler, you'll see that the only thing a type has to have defined on it is a function signature called serve HTTP that takes in two arguments, a response writer and a pointer to the HTTP request. The other way to do this is there's one called handle func, which instead of passing in a variable of the type that implements that interface, you just attach in a function that the function signature is essentially the same thing as the serve HTTP function that needs to be defined on the handler interface. So we're going to use this one first because we're not going to get to the handle part yet. That's a little more complicated. So what we're going to do here is, before we actually start the server, we're going to do http.handle func, and we just want this to be on the root path. And I'm just going to pass in an anonymous function here. and it's going to be first argument is the response writer. Typically, you see this called W, and it's http.response writer. And then the second argument is the request, and typically you will see this referenced as R, and it's a pointer to http.request, and it returns it doesn't return anything. And we're just going to do a fmt.fprintf, which is used to take a string and basically write it into something that implements the writer interface, which response writer does implement that. So I'm going to pass in the response writer, and then I'm just going to do the classic hello world. Okay. So we have this now, and now you'll see if I start the server and I curl localhost, you get hello world. Okay, so we've added our first route at this point. All it's doing is it's saying hello, but it's a route nonetheless. So let's kill this now. So REST APIs, usually you use them to allow access to certain resources on your system. And so we're going to have a product. We're going to have products. That's what we're going to interact with. The way I like to do this when I'm just kind of writing this from scratch is, so we're going to define a struct that is going to implement that handler interface. You remember from over here? And so basically we're going to have a type that actually has this function, its function signature defined on it. So we're going to go up here, and let me look at my notes real fast. Okay. So first we're going to define what our product actually looks like. So we're going to have type product, and it's a struct. And I'm not actually going to give these IDs. So I'm going to store them in a slice. And the shortcut I'm going to basically use is that the index of where they're stored in the slice is the ID. That's kind of the janky way I'm doing to get around that right now. So it has these have two properties. They have a string, or a name that's a string. And I'm going to make use of the tags you can set on structs to add some additional functionality when used by certain other packages. And there's a JSON tag, which what this will do is, if you are marshalling JSON from or to the struct, if you're marshalling JSON into the struct, if there is a field with this key here, name, it will put that value in this property. And vice versa, if you were to take a struct, this product struct, and actually unmarshal, or marshal it into JSON, it would yield a key here of name with the value equal to whatever the value of name is on this struct. And the second one we're going to have is price, which is a float 64. And it's going to have a JSON tag of price. And just to have a convenient type alias, I'm going to have a type of products, which is just a slice of product. So I want something to handle all the routing for the products. So I'm going to define another struct here. I'm just going to call it product handler, and it's a struct. And the first thing it's going to have is products, and it's going to be of type products. So it's basically just a slice of products. But there's something else I'm going to pass in here, and I'm going to explain why. I'm going to say it also has embedded into it another struct from the sync package called mutex. This will allow each individual request to lock this when it needs to use it, and there's a reason why. So when the way the HTTP server is implemented in Go, each request spins up a new Go routine. So that means there's a possibility that there will be requests being handled concurrently, if not even in direct parallel. Depending on what they're doing, you're introducing a race condition where one request may modify the product slice before another request is able to read from it, and it would cause some inconsistency. So what this is going to enable us to do is to lock this product slice per request to do whatever it's going to do, and then unlock it so the other requests can operate with it. this is kind of mimicking the way that like a SQL database table would work, at least the way I kind of know how it works in MySQL, where when you go to read from the table, it will like lock either, depending on, we're not going to talk, this is not about MySQL, that's a whole different video, but it's going to like lock the table temporarily so that the other requests, the other queries can't use it. It's basically what it's mimicking. So we have our product handler now, and you'll recall that in order to have this product handler implement the handler interface, it just simply has to have a function defined to it called serve HTTP with those 2 arguments. So I'm going to attach this function to product handler, and it's called serve HTTP, and it has those two arguments, and they usually are called HTTP response writer and R for HTTP request. Again, doesn't return anything. And let me look at my notes again real fast. Okay. So this is what I'm going to do here with this is going to handle the request differently depending on what the method, the request method is. So whether it's a GET request, POST request, delete request, stuff like that. So the only thing this is going to do is it's going to switch on, we're going to reference the request, and there's a property on it called method. Okay. So we're going to do some case switching here. So case, if it's get, we're going to call another function attached to this struct called get, and we're going to pass in the same request, the same response writer and the same request. Okay. So, and we're going to do the rest of them. So post ph.post, you're probably picking up the pattern here. Case, so put and patch are kind of used interchangeably to update resources. So I'm just going to have them both call the same function. So we're going to have put and patch or ph.put wr, and case of delete. I can't spell today. There we go. ph.delete wr. And then we're going to have a default case. And so before, what we're going to do is we're going to respond with an error. And we're going to be doing this a lot depending on when certain conditions happen. So I usually go ahead and actually put this in its own separate function. Let me look at my notes again real quick. Okay. So there's 2 functions I'm going to define here because we're going to use these a lot. The first one is going to be, we are going to have a function that we use to respond with a request with a JSON payload. So I'm going to have a func called respond with JSON. And it's going to take in that response writer, http.response writer. And I want it to pass in the HTTP response status code, so like 404 or 200, stuff like that. So an int, and then the data that's going to be put in there as a JSON. There's a kind of like a way in Go you can say of this type can be basically anything, which is a empty interface. This would be the equivalent of the like any keyword in TypeScript. It basically says this could be anything. It doesn't really matter what it is. So there is a package called an encoding/JSON that you can use to marshal and unmarshal data to and from JSON. And when you use that, you get 2 things back. You get the actual JSON, or the JSON in the case of you marshaling it, or if you unmarshal it, it'll go straight into a variable. So when we marshal it, we're going to get back the byte slice of bytes that is the new JSON string, and an error. So we're going to do JSON.marshal, and we're going to marshal this data. In this case, I'm being lazy and I'm just ignoring the error. Typically, if you're wanting to do this in like a production system, you obviously don't want to ignore the error. And see, on the response writer, I'm going to access the header, and I'm going to add a key here for content type to indicate that the response is of type application JSON. And so we're going to write header, and I'm going to write to the header the status code, so code. And then finally, we're going to write the response. So write response. See, now once you've written to the response, once this entire thing returns, the server will actually send the response back. And the reason I went ahead and made that function is because you recall I said that we were going to have to respond with an error. Well, the respond with error is just going to use respond with JSON, but it's going to just pass in a something that just returns a JSON message that just says, hey, there's an error and here's the error. So it's going to be func respond with error, and it takes in that response writer, and the arguments are basically the same thing as JSON, except we're going to pass in a message, the error message, a string. And all this is going to do is it's going to respond with JSON, passing in the writer, the code, and then the thing I'm going to pass in as the data is a map with string keys and string values, and it's just going to have error message. So that'll just return a simple JSON string of the error key, and then whatever the actual error message was. So then we'll go up here to default, and I'm going to say, go back here, respond with error, passing in my writer, HTTP. The HTTP package actually has all of those status codes defined in them too. So I'm gonna do status, and I'm gonna do a little auto completion. Status method, yeah, method not allowed. That's what I want. And the message I'm just going to say is invalid method. That's all I'm going to say. You can obviously be a little more informative with your errors, but that's all I'm going to put on here. So we have all of these different cases being handled. Now we actually have to define these functions on our struct. So I'm going to do func ph product handler. Now I'm just going to have get, and it's going to take the same arguments as the serve HTTP response writer r http dot request. Let me go back up. No, my brain. And I'm just going to head and copy this real fast because the only difference between these three initially is just going to be the name. So I'm going to paste that 3 times. Let's see, this is going to be post. This is going to be, oops, back. Change word. Okay, this is going to be put. Change word. This is going to be, I can't keep hitting the wrong keys. Delete. Delete. Okay. So all these are going to do probably initially until we actually get like some more concrete logic in place is they're just going to do like kind of similar to the hello world thing where it's going to do like fmt f print f, and we're going to tag in this, and I'm just going to say hello from get, yeah, something like this. So I'm going to copy that. I probably should have did this before I even did the other things actually. Pass this in, go all the way to the end, paste that in, clean this up a little bit, go to the end, paste this in, oops, oh yeah, I was like, why is the blank lines? And we'll see, this is from get, this is from change word post, hello from, bro, I keep hitting the wrong key so much, put, and this is delete. Okay, So now we actually want to set our server so that it's going to actually use this. We're also going to want to create a new product handler and already have some just some products already there. So I'm going to define one more function here called new product handler. Oops, handler, can't spell handler, there we go. And it's just going to return a pointer to our handler. I'm going to return product handler. Let's see, products is going to be products. Let's see, product. So they have a name and a price. So let's just say we got shoes, and they're $25. And we have another one, say a webcam, and it's $50. And then one more, we're gonna do a mic, or like a microphone, and it's $20. And let's see, put this here. Is that good? Okay. That should be good. Okay. So now we're going to actually create our product handler equals new product handler. We're going to do http.handle, and the pattern we're going to use is I use two patterns here, so that you'll see this declared twice. We have products with no trailing slash, and we're going to pass in our product handler to handle this route, and then it's going to have the same thing. Only difference is we're going to have the trailing slash because these are actually handled differently. And the way that REST APIs typically, when you reference like a specific resource in them, you put like the ID of the resource you want to interact with like at the end of the URL. So like at the end here would be like a 2 or a 3 to indicate like what the ID is. So at this point, we should be able to start this back up again, I believe. Oops, I made boo-boo. What did I do? Undefined. Oh, it'd help if I actually spelled this right, huh? Printf. Let's see. Dot. Too many values and product literal. There. Shouldn't be. 66. Okay. Oh, whoops. I put a comma there instead of a dot. Okay. So let's try this again. Okay. So if we curl this, if we curl the root, we still get hello world. But now we're going to want to, let's curl products. Hello from Git. Nice. Okay. So what else do we want to do here? We want to, what is it? It's a dash request, right? Request. And we'll say post. So this should make it a post request. Hello from post. Nice. Okay. Let's do put. Hello from put. And let's do delete. Hello from delete. Okay. So all the route handling for the products is now set up. So now we actually want to do something with them. So the easiest one to do is we're going to do the get. That's the most straightforward one. Let me look at my example real quick. Okay. So let's go back up to the get. Okay, here we go. So the first thing we want to do is if they go to the products URL with no ID, we're just going to give them all the products. Okay, straightforward enough. So all we're going to do is we're going to defer. Remember, we have a mutex on this product handler, so we're going to lock it. but I'm going to do a defer unlock to make sure that when this function's done, that the mutex is properly unlocked. I'm going to do ph.lock to make sure that this request is the only one able to interact with the products until it's done reading from it. And then it's just going to do a respond with JSON, passing in the writer, HTTP, status. I think it's okay. Okay, yeah. And then the thing we're going to have marshaled in the JSON is just ph.products. This will just basically give us all of the products that we have defined, which, if you recall, right now there's only 3 of them. So if we do that, where'd my thing go? Sorry, curl localhost. And I'm gonna pipe it into this this like terminal JSON processor called JQ, just so you can get like a pretty print and the like a color syntax and stuff. I'm gonna pass it in there. Oopsie daisy, don't forget to remove this, so it actually writes the freaking JSON data to the request, because I'm a genius. And it would probably also help if I actually restarted the server. Yeah, that would probably help a lot. Hey, there we go. If you look through here, you see we got a JSON response with our shoes, our webcam, and our microphone. Yay! So what's the next thing we want to implement on here? Well, if they pass in, if this is going, say, like localhost 8080 products /2, you want to give them only the product in the index of the slice where the index is 2. So we're going to do that now. So we're going to be having to grab that ID a lot. So I'm going to also add another little convenience function down here. I'm going to call ID from URL. Yeah. Let me again look at my notes as I keep calling them my notes. Where is my? Here. Okay, here it is. And it's only thing I'm going to pass in here is the request, because I need to pull the URL off the request, and it's going to return 2 things. It's going to return an int, so the ID that I hopefully pulled from the request or from the URL, and an error if there was a problem. So we need to split the URL by the slashes, and there's an easy way to do that. I'm gonna call the split URL parts, and I'm gonna use the strings package, and there's this function called split, and you pass in the string you want to split and then the delimiter to split on. So we'll reference the request and the URL property, and then string to get a string representation of it, and then the slash to give us the parts. So we got to do some sanity checks here. First thing we want to see is, based on what we have right now, if there is an ID, the parts slice will have 3 parts, because it'll have the base, the base URL, the resource we're interacting with. So in this case, it's products, and then the last one will be the ID. In other, like the third-party routers that make this like much simpler, they use like regex to do it, but I suck at regex, so don't ask me to teach you regex. So I'm going to do it kind of a sort of naive way, which is I'm going to check if the length of parts is not equal to 3. If it's not equal to 3, that means there's no ID. So I'm going to return 0 and errors.new. And the error I'm just going to return is not found. Because typically that means that the resource they're trying to interact with isn't there. So now we need to convert that ID we got from the URL into integer, so we can use it as a to get the index out of the slice. So we're gonna do ID error equals, there's a string a package that basically convert like different types of strings and them to from and strings, stuff like that. and we're going to do ATOI, which is used to convert a string into an integer. And what I want to convert is the last value in that slice, because that'll be our ID. So parts, and then I want the last value, so length of parts minus 1. That'll give us our ID. If for some reason that didn't work, I'm just gonna still return more or less the same error. Error 0, return 0, errors.new, not found. It's messed up, man. And then finally I'm gonna return ID and nil to actually give us our ID. So let's go back up to our get function. Where you at? There you are. Let me check my references. Okay. So we need to get our ID, or check if there is an ID, is like put. So ID error equals ID from URL, and we're gonna pass in our request. Now, if error does not equal nil, that means we got, or if there was an error, that means there is no ID. So we're just going to give them all of the products like before. So we're going to move this in here like this. Otherwise, we want to give them the specific product. We're going to do a little sanity checking here. I think I use the sanity checking thing. I think I might just end up copying it around, but you could put this in a separate function, or maybe even attach it to the actual product. That would be good too. So I'm going to do if ID is greater than or equal to length of the product slice. Because what this will mean is they gave you an ID that doesn't exist. Because remember we're using the indexes of the slice as IDs. Because if the ID is greater than length, you would get like an index out of bounds error. Or if ID is less than 0. If it's either one of these two things, it doesn't exist. So we're just going to do if either one of these two things is true. Oh wait, I forgot one thing. Since we're responding, we don't want to continue anymore, so we're going to do return to make sure that we don't do anything else here. We're going to respond with error. Again, passing in the writer, HTTP reduce status. What is it? It's not found. There it is. And I'm going to pass in just the error message is not found. I know, real descriptive. And they're going to return because we don't want to go any further. But if that sanity check is fine, we're going to do respond with JSON w HTTP status okay, and we're going to do product handler dot products, and specifically the product at index ID, like that. So if I remember to restart the server this time, if we do this again, we'll still get all of them. But if I say do 0, you only get 1 this time. You get the product that's in the first, or the product that's at index 0 in the slice. Okay, so our get handler is basically done. So next we want to be able to create these products. So let me stop the server so I don't forget to restart it again like a dum-dum. Get rid of this so I don't forget to get rid of that like a dum-dum again. So first thing we're going to want to do is read the body of the request to get the JSON data. After you're done reading the body, the good practice is to close it. So I'm just going to put a defer here for the request body and it calls the close function on the body to close that buffer. So we're going to do body.error, or body and error equals, we're going to use the IO util package, and it has a function called read all, and it takes in anything that implements the reader interface. And conveniently, the body does do that. So this will read all of the contents of the body into this variable right here. If for some reason it don't work, for some reason I can't process it for some reason. That sounds like a boo-boo, so I'm going to do respond with error, passing in our writer, HTTP, status. This is kind of it doesn't really have like a reason, I guess, so we're going to do internal server error. Yeah, we'll do that. And then I'm just going to return the actual like error itself as a message. And we're going to return. Okay, let's see. So let's actually enforce that what they're sending says it's JSON. So I'm going to say CT for content type equals R for the request, the header from the request, and we're going to get the value of the key content type. I'm going to check if content type does not equal application JSON. And I'm going to respond with error. You probably figure out the formula at this point. Status, is it unsupported media type? And I'm going to say content type application JSON required. Okay, and then return. If you always remember, if you are responding at this point, you always return, because at that point there's no reason to keep going. So we have our body. We're double checking that they are saying it's JSON. So now we need to unmarshal the JSON payload we received into a product struct. And the easiest way to do that is we're going to declare a new product without initializing it. And then we're going to use another function in the JSON package called unmarshal. And the only thing it will return is an error if it doesn't work. So we're going to do error equals JSON.unmarshal. And it has two arguments. First argument is the byte slice that represents the JSON. And then the second argument is a pointer to the variable you want to put the data unmarshaled from the JSON into. Then we're going to check if there is an error. We're going to do respond with error HTTP. We're going to do status. What do we call it? Sort of a bad request. If you sent me something that I couldn't unmarshal, it was you goofed. So bad request. And I'm going to just return the error as a message. Return. So at this point, you have your JSON payload unmarshaled into an actual product struct. So we need to actually append it to our product slice. So if we're touching that slice again, we're going to lock it, and I'm going to defer a unlock to make sure it actually gets properly unlocked. ph.lock to make sure I'm the only one that can mess with it. We're going to do ph.products equals append ph.products, and we're going to append the product. And then we're going to respond with our newly created product. So we're going to respond with JSON, pass in the writer, HTTP, status, is it created? Created, there it is. And I'm going to pass in the product we just passed in to get marshaled as JSON. Okay, so now we should be able to make new products. Okay, so we're going to run the server again, and I should have one here somewhere where I had the actual I didn't. Let's see, request. Let me give me a second. Curl request is post. Yeah, okay. Well, that's not quite what I wanted. Oh, let me find I have this in here somewhere where I actually was like creating a product. I have to find it. Here it is. So you'll see here I am curling where I'm setting the header to content type, because otherwise it'll complain and reject it. I'm indicating that it's a post request, and I'm passing in this little JSON string here with name of monitor, and the price is set to $80, like a computer monitor. And then I'm posting it to products. So we're going to send that, and you'll see I got back a response of monitor price. Now, just to make sure that we actually add to that, let's send a GET request to that like this. And you will see that now there are now 4 entries here, with the 4th one being the monitor we just added. Cool. So we can query for the products, query for one product, and post new products. So now let's be able to modify one of the existing products. Okay. So let me stop my server so again I don't forget like a big dum-dum. And let's get rid of this. We go look at the notes, he says. Look at the notes. And a lot of this I am going to copy from the last one. So I'm actually going to copy like a lot of this, and we're going to change it. So yoink, we're down here. Put y'all down here. So we're going to change this a little bit. So this one is actually good. This one should have an ID because we're wanting to modify a specific product, right? So we're going to do ID error equals ID from URL or excuse me. If error does not equal nil, you didn't give me an ID or it's borked. So we're going to respond with capitalize it, thank you, error w http status not found error.error. Okay. Then return. So this is to make sure that we actually are getting an ID from the URL. Let's see, we're getting the body because we still need it to unmarshal into a product struct. We still want to enforce the content type. Okay, we're unmarshaling it. This is all still fine. This all looks good. Yeah, okay. So before this is where this is going to start getting different. So we need to make sure that again the ID we were given actually exists within our slice. And I'm going to go yoink that from the where did I put that? The ID thing right here. So I'm gonna, or no, what was that? I didn't do that yet. Oh wait, it's from the get function. There it is. Yeah, this. I'm going to yoink this because this is basically the same thing. Let's go down back to here. Where'd you go? Where'd you come from? Where'd you go? Okay, here we go. I'm going to paste this here because we still want to make sure that, again, that ID still is within the range of our slices indexes. And then I'm going to basically check and see whether the product that was unmarshaled actually has like new values. So I'm going to do if product dot name is not equal to an empty string, meaning it didn't have a value. Then I'm going to do product handler dot products at the ID we were given, and I'm going to change its name to product dot name. And then, as you can probably guess, something similar, but for price does not equal 0 ph.products ID price equals product.price. And then finally, we're going to get rid of this, and we are going to respond with not created. Okay, and we're going to return the newly modified product. So we're going to be excuse me, ph.products at ID. So now we should be able to change one of the products we already have in here. So let me run the server, and let me clear this so y'all can see it. Okay. So I should have a put request one here that was tweaking with earlier. Keep going. Oops. It helped actually put curl. Okay. See. Give me the put. Okay. So we are changing the price of the product in index 2, which I believe should be the microphone, to $60. We're getting a little more. We're upgrading our hardware. We're gonna raise these up to $60. So just to show you that this is right, before I actually run this, let's get the grab all the products. So you'll see right now that Mike has a price of 20. And let us do we'll just run that put request now. What is it? There it is. I'm gonna run this, and you'll see we also get back the product that it modified. So just to make sure that that's right, let's actually specifically only query for that one, and you'll see now that the mic has a price of 60. Yay! So of the CRUD acronym, we have the create, we have the read, we have the update. Last but not least, we need the delete. So let's go, let me clear this, let me stop my server. So let's go down to, last but not least, delete. And let me go look at my stuff. Okay. So we need the ID first and foremost. Excuse me. So ID, error equals ID from URL, passing in the request. Excuse me, if error does not equal nil, respond with error, HTTP status not found, not found. You gave me a bum ID, but return. So we have our ID. We need to do that sanity check. Again, you could probably put this in a function or something somewhere. I'm just being kind of lazy about it. I'm just copying it. We need to make sure that our ID is within the range of our slice. Let's see. Or actually, before we do that, because we're actually interacting with the slice now, we're going to lock it. So I'm going to do defer unlock ph.lock lock it. Let me see, make sure. Okay, so the way I'm going to remove these is I'm going to switch the last item in the slice with whatever the index is of the item that they want to delete, because I'm going to trim the last thing off of the slice. So what I want to check is the ID that was given to us, is it the last item? Or is it not the last item? Because if it is, I need to do a swap. So to do that, I'm going to do if ID is less than the length of our products, excuse me, -1. And if it is, we need to swap them. So we're going to do, this might be a little convoluted. Products at length ph.products -1. And I'm taking advantage of the fact that you can return multiple values from a statement in Go at the same time. ph.products at ID. These are going to be equal to, and this is like a trick you can do in Go, since you can return multiple values, is what I'm basically going to be doing is I'm going to be switching these. So I'm going to say that the first result is equal to ph.products at ID, and the second one is ph.products length ph.products -1. So this may look a little weird. This is a trick you can do in Go with slices specifically, since you can return multiple values like this. Is what this is happening is, you notice these are both the same things, they're just flipped. So what is happening is they're basically being switched. This is like a little trick you can do to swap values on a slice in Go. And so now we're going to trim the last thing of the slice off. We do products, ph.products equals ph.products. And we're going to use this like little like range syntax to select, to get like a subsection of the slice. And then the first it's delimited by this like colon. The first number is the starting index, and it's inclusive. And then the second value is the ending index that you want to grab, and it's non-inclusive. And if you don't provide a value at the first one, it just assumes it's the first value, so 0. And I'm going to do length ph.products -1. Now remember, because this second part of this, like grabbing like a section of a slice syntax, this second one is non-inclusive. This will basically just drop the last item. And since we switched them, if we needed to, we will have dropped the item we don't want anymore. And then finally we respond with JSON, and it's customary when you're doing a delete request that you don't return anything. So you do HTTP status no content. Yeah, there is no content. And then I'm just gonna pass it an empty string because it basically won't marshal into anything. So this should be good. This should actually work funky dory. So I'm gonna run, and I'm looking for my delete request. Where are you at? I might pass it. Okay, yeah, here we go. So I'm going to delete the first item out of the slice, which, if we recall, actually let me do, if we recall, that would be the shoes. So after I run this curl command that I was just looking at a second ago, here it is. The shoes should not be there anymore. So I'm going to run this, and again, I didn't get an error, so presumably this is fine. And I'm going to run this, and now there should only be 2 items left: the webcam and the mic. So you'll see, yep, it's gone. So what? And remember, we're also doing some error checking. So what if I pass in something that doesn't exist, like 5? There's no index 5. Oops. You get error not found. So we are properly checking to make sure that's right. Let me do something else derpy, like say it's -1. Okay, not found. Cool, great. And let's keep getting rid of them until there's nothing left. So this should get rid of webcam. Or yeah, that got rid of mic, right? Okay, mic. Yeah, sorry. Yeah, mic. It messes the order up around, but I don't really care about the ordering for this. And then let's get rid of that last one. So we should have nothing. Okay, it's empty, which makes sense. And if I try to delete now, I'll get not found because there's nothing in there. So there you go. You essentially now have a fully functioning REST API for these products. You can you can read new products, or read from the products you already have, create new ones, update existing ones, and delete the ones you don't need anymore. If you wanted to build from this, probably a good starting point would be to replace this in-memory storage with like some kind of persistence, like either a file system based one where you just write this stuff out to like a JSON file or something. An actual database, whether it's SQL or NoSQL, doesn't matter. You could also now properly integrate an actual third-party router, maybe there's a really good one called Gorilla Mux that you'll see used in a lot of other tutorials. But I just wanted to demonstrate to you that you can actually create essentially a fully functioning REST API just using the Go standard library, which is pretty cool, I think. That's all I got for you today. If you have any questions about creating this API, or if you get stuck for some reason, leave me a comment down below, and I'll try to help you out if I can. If you have any other suggestions about some other things you would like to learn about Go, you can also leave me a comment down below, or you can join my Discord server and just leave me a message and tell me what your suggestion is. And with that, y'all come on back now, and I'll see you next time.